Prompt Engineering 101. Add think step by step to the end of every prompt you write. Right? Right? Well, that seems to be the consensus. We've been told that step-by-step thinking, also called COT, chain of thought prompting, improves accuracy. But here's the question. What if those steps just create a bigger attack surface? In this paper, the authors present a new adversarial framework called CTTA, chain of thought transfer attacks. Their system is designed to exploit these kinds of reasoning processes. The authors show that by crafting inputs which specifically target intermediate reasoning steps, attackers can drastically reduce model performance across tasks like sentiment analysis, reading comprehension, and natural language inference. And importantly, the attacker doesn't need to write your prompt for you. This isn't a problem that comes from copying and pasting prompts from untrusted sources. Not at all. This can be a problem for prompts that you write from scratch. The attacker just needs to augment the data that the model looks at while it's generating the response. For example, if your model is reasoning over a batch of customer support tickets, all the attacker needs to do is submit a malicious customer support ticket into your system. And this alone can kind of nudge your model's reasoning off balance, destabilizing your system. If they just modify a few characters, spell a few words in a weird way, or swap out commonly used words for other ones, it can have an effect. No prompt injection needed. You could be looking at that malicious support ticket and see no reason for alarm, no weird characters, just normal text, normal words, normal sentences, but crafted in a way that throws off your LLM. And unfortunately, there will be no way for you to tell that the results you're getting from your model are wrong. The output will also seem completely normal. It just won't be right. On today's episode of Journal Club, we're going to unpack how these attacks are built, why higher performing models are actually more vulnerable than lower powered ones, and what the authors found when they traced attention shifts inside the models during these exploits. We'll also look at how adversarial examples from one model can actually transfer to others and what that means for anyone deploying LLMs in production. If you're already subscribed to our email newsletter, then you'll be getting this episode in text and audio form delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.